Hi, in this video, we are going to talk about parallel states and how we can use them to handle concurrent tasks with XState. By default, a state machine can be in only one state at a time, but sometimes it can be useful to orchestrate several concurrent operations. This is what parallel states are for. In this state machine, uploading state is a parallel state. It has two children, back state and front state. All the child states of a parallel state are active at the same time. Back and front states are active, and they can handle events independently. Usually, children of a parallel states are called orthogonal regions. We are going to use this application to implement a parallel state. Currently, in this to-do list application, we can check and uncheck to-dos, and we can create a new to-do. We are going to make the refresh button work. When we click on refresh button, we want to make a request to the server that sends the to-do list. As we are not making real requests in this application, we are going to mock them. And we are going to say that when we click on refresh button, we'll simulate that another user has added in the meantime a to-do list. So when we click on the refresh button, we want the to-dos to remain the same, but we want to see another to-do added to the list. All the logic of the application is driven by a state machine. The state machine has three important steps. First, we fetch the initial to-dos. Then, if the fetching failed, we go to a failed state. And finally, if we could get the to-dos, we go to to-dos management state. In this state, we handle to-dos creation and to-dos updating. We want to wrap this state in another state, and this state is going to have two children, to-dos management and to-dos refetching. We want these both things to be handled separately. So we create a new state called fetched initial to-dos. This state is of type parallel, and we put the to-dos management state. We are going to hide the details of to-dos management state. Okay, now in fetching to-dos, we have to update the target of the on-done transition. It's no longer to-dos management, but it's fetched initial to-dos. Okay, does it still work? If we go back to the application, we can see that we can still update to-dos and create to-dos. It works. Now that we put to-dos management in a parallel state, we are going to create the other orthogonal region we want. It's refreshing to-dos. In this state, we are going to have several states. First, we have other idle state. In idle states, we are waiting for the user to press a refresh button. When the user has clicked on the refresh button, we are going to refetching to-dos. If the fetching failed, we go to failed to fetch to-dos, and the initial state is idle. Now, let's create the event we will send to the machine when we click on refresh button. So, in the events union, we create a new event called refresh to-dos. We take this event, and on idle state, when we receive it, we target refetching to-dos. When we enter in refetching to-do state, we want to invoke a service that is going to fetch the to-dos. So in refetching to-do state, we invoke a service we will call refetch to-dos. We can type this service. We go to schema property, services, and refetch to-dos will return an array of to-do items. When the fetching is done, we go to idle state. If the fetching fails, we go to failed to fetch to-dos. When we could get the to-dos, we are going to assign them to the context. So on undone transition, we assign refetch to-dos to context. If the fetching has failed, we want to let the user retry the operation. So on failed to fetch to state, we are going to listen to a refresh to those events, and when we receive it, we target refetching to do state. Now that we modeled the state, we can declare refetch to do's service and assign refresh to do's to context action. First, we declare the service. We go to services option and we declare refetch to do's service that is going to wait for 1 second, and then it will return what to-dos are in context plus another one. So we are going to return context.todos plus another to-do. Perfect. Now we can declare the action. The action is assign refresh to-dos to context. And it's going to do the same thing as the action that is called when initial to-dos have been fetched. So I let the copilot code for me, and it does it quite well. Now that we have declared the service and its assigned action, we can go to the page and say that when the button has been clicked, we want to send an event to the machine. Handle refresh to dos is called when the refresh button is pressed. So in this handler, we send an event to the machine. We send refresh to dos event. If we go back to the screen and we reload, if we click on the refresh button, 1 second later, we can see that to-do created by another user has been added to the list. We can do one more thing to improve the UI. Refetching to-dos is a constant that is used by refresh button to display a loading state. We want to display a loading state to refresh button when actually we are reloading to-dos. So we go back to to-dos machine and we are going to declare a tag in refetching to-dos. Refetching to-dos is a perfect name. Now in the page, we use state as tag refetching to-dos. When we refresh to-dos, we see a loading state on the button. Refreshing to-dos works. But what does occur if we refresh to-dos and we create a to-do at the same time? Let's take a look at something that is possible. At T0, we refresh to-dos and we create to-dos. we launch those both actions simultaneously. Say that the request for Todos refreshing comes to server before the request for Todos creation. At this moment, the server does not know about the to-do we just created, so it won't include it in the response. Now, say that the response for Todos creation comes back to the browser before the response for Todos refreshing. It means that the to-do would be acknowledged and would be added to the list client side. But it also means that some second later, when the browser receives the response for to-dos refreshing, the list would be overridden. The to-do we just created would be discarded and the list without it would be displayed on the screen. This is a critical situation, I agree. But this is something that a state machine currently doesn't handle, and I think it should. Let's have a look at this scenario in the browser. We can increase the delay before refetch to do service returns. Say that it returns after 10 seconds. We refresh to-do list, and in the meantime, we create another to-do. The to-do is acknowledged and displayed on the list. The refreshing still occurs. And after some time, the refreshing resolves and the list has been updated with a to-do created by another user, but the to-do we just created has disappeared. This is the issue. When using parallel states, synchronization issues and race conditions can appear. We can use cancellation to solve this problem. When we submit a to-do and when we update the status of a to-do, we want to cancel the refreshing of the to-do list. We can leverage a feature of parallel states called broadcasting. Broadcasting is the fact that when a machine receives an event, all its active orthogonal regions receive it. The event used by to-do's management state to confirm the submission of a to-do is save to-do. The event used to update the status of a to-do is update to-do status. We go to refreshing to-do's orthogonal region and to its refetching to-do state. Here we listen to this event, save to-do, and to update to-do status. When we receive one of these events, we want to target idle state. It means that we cancel the refreshing of to-dos. So target idle and the same thing for update to the status. Let's try if it works. We go back to refetch to-do service and we set a timeout of 10 seconds. So we refresh to-dos, the button is in loading state, and we create a to-do. When we submitted the to-do, you may have seen that the loading state has disappeared. It means that the refreshing has been cancelled successfully. Let's see if it works too for updating to-do. We refresh to-do's list and we update to to-do. Refreshing has been cancelled too. Parallel states are a powerful feature that brings concurrency to state charts. But concurrency brings its own issues. Synchronization and cancellation may be required, but they can be solved idiomatically with state charts. Parallel states have other interesting features. For example, when all the orthogonal regions of a parallel state are tone, the parallel state itself is tone. It acts as a promise.all in JavaScript. It may be the subject of another video. Thank you for watching and see you soon.